Hello and welcome to this webinar by AVTECH. Today we will discuss how ProFlight can help you save fuel and time, enhance turbulence safety, and decrease CO2 emissions for a sustainable flight operation. Today's agenda includes a brief presentation of AVTECH services, followed by an overview of the features offered by ProFlight. We will then proceed to our 10K turbulence forecasts, which are complemented by the measured data from IATA Turbulence Aware. Then the science behind the thunderstorm layer in ProFlight will be explained, and it will also be discussed how it is displayed and utilized in the user interface. Lastly, we will summarize the benefit of having an all-in-one solution. During the presentation, we encourage you to jot down any question that may arise, and please feel free to contact us if you need any additional information regarding our products and services. My name is Per Öhman, and I'm a former SAS pilot and key account manager at AVTECH. I will be joined by Caroline Reitwiesner, PhD in meteorology and CEO of WX Fusion. Let's have a quick look at the AVTECH services. Every day, over 7,000 flights benefit from AVTECH services, resulting in more than 16 million data uplinks to date. We optimize each flight based on aircraft performance parameters, actual flight route, and high-resolution weather to make every flight efficient, safe, and eco-friendly. ProFlight is trusted by over 2,600 pilots, and we are proud to make a difference through our close collaboration with our customers. And now moving on to ProFlight. We really believe ProFlight to be the best EFB weather application available. What makes ProFlight truly unique are its three main powerful functions: tailored high-resolution turbulence forecasts with minute-level accuracy, real-time CV data from WX Fusion, and real-time measured turbulence data from IATA. These functions complement each other, providing pilots with an unprecedented level of situational awareness. Let's have a look at the features of ProFlight. They include high-resolution weather with tailored turbulence forecasts, climb and cruise winds, dynamic descent winds, as well as standard low-resolution weather information such as significant weather charts, turbulence, and icing conditions. It also offers interactive SIGNUPs, which allows you to select global SIGNUPs or SIGNUPs tailored specifically for your flight. Additionally, ProFlight provides metal and TAF reports, CB Global from WX Fusion, IATA Turbulence Aware, Motne and Snow Time Decoder, and organized tracks. Here is a look at high-resolution weather forecasts. Okay, so why is high-resolution weather forecasts superior to standard weather? The answer is simple. We collect native data directly from the UK Met Office supercomputers. Due to the large amount of data they produce, this is normally not possible. That's why AVTECH has built a system that constructs a 4D volume around each aircraft's route and retrieves data specifically for that volume only. This approach allows us to utilize high-resolution data in our services. The weather forecasts are tailored to predict the weather based on each position along the route in both time and space. This image demonstrates the difference between standard low-resolution 140 km grid and high-resolution 10 km grid weather forecasts. The difference horizontally can clearly be seen in this illustration, with a high-resolution turbulence in the upper section of the picture and low-resolution in the lower section. High-resolution forecasts offer additional vertical levels and a higher time resolution of 1 hour. Here's another example showcasing the difference between high-resolution and standard aviation weather turbulence forecasts, both available in ProFlight. Again, high-resolution on top and low-resolution at the bottom. Let's explore how this is displayed in ProFlight. Consider this example flight between Stockholm and Chicago, which shows turbulence information based on standard aviation weather. Unclear information raises questions about whether route changes are necessary. Should the pilots hope that there will be no severe turbulence and follow the flight plan, or should they request a route change? Here's the same flight, but now with a high-resolution turbulence layer activated, providing more reassuring information. The green patches accurately depict light turbulence expected at a planned flight level. This information is also displayed in the vertical view. This feature helps pilots a lot in their decision making, and our feedback is that they find it to be accurate and timely. With the low-resolution turbulence layer removed, the flight shows only light turbulence along the route, further reassuring the pilots. In this picture, the IATA turbulence layer is activated, providing real-time measured data from airlines participating in the IATA Turbulence Aware program. The colors correspond to the high-resolution turbulence information, indicating moderate and severe turbulence south of 65 north, 30 west. ProFlight is designed to ensure safe flight operations by keeping you updated and avoiding severe and hazardous weather and turbulence. Now I will hand you over to Caroline, who will explain the science behind the CB Global service and how it is integrated into ProFlight.
Thank you, Per. So, as you probably all know, convective turbulence and thunderstorms endanger aviation safety and generate considerable costs. In these three images, you can see three examples what can happen when an aircraft encounters thunderstorms. So here this aircraft encountered a hail cell and is heavily damaged. So this is a lightning strike here in the middle. And on the right-hand side, you have icing of the pitot tubes. So all these phenomena can be very dangerous and they can cause injuries and fatalities, damaged and grounded aircraft, and of course delays. A Eurocontrol study in 2021 says that severe thunderstorms cost aviation 2.2 billion euros in terms of en route delays. And if we keep in mind climate change, we can expect that weather extremes increase in intensity in the future. So why do turbulence and thunderstorms still produce such huge amounts of costs? Well, it's simply because the standard weather information is too vague. So let's have a look at the pilot's view. In this onboard radar image, you can see two thunderstorm cells reflecting the radar beam back, such that behind the cells, the onboard radar is basically blind. So there's an attenuation of the onboard radar signal behind these two thunder cells. So basically, the pilot cannot see behind the cells, and in addition, he only sees a sector, so he cannot see what is to the left or to the right of the aircraft or behind. Pilots simply do not have the full overview of the weather situation. In addition, especially when you are on a long-haul flight and the aircraft is, for example, not equipped with connectivity, the weather forecast charts that are used on board of the aircraft are simply outdated. And another important point is that weather forecasts can only give you a rough estimate on where and when a thunderstorm will occur, but they cannot predict the exact location and time of thunderstorm occurrence. We at WX Fusion provide a solution for this issue. So what we basically do is that we use satellite data, ground-based weather radar data, and lightning data to identify turbulence and thunderstorms from observations. And then we use a data fusion artificial intelligence algorithm where we combine all these data also with model forecasts and produce our products. One of our products is called CB Global. It's relevant for the upper airspace, so for en route traffic. And this tool uses mainly satellite data, and we combine different spectral channels measured by the satellite in order to identify the most active parts of the storms, which is indicated by this red bold contour here. So we do not simply encounter with this contour the whole cloud, but only the really active parts where you can expect dangerous phenomena for aircraft. So these hazard areas are also forecast up to 1 hour, indicated by this dotted line here. So with one view in this product, you can see where the hazard area is and where it will be in 1 hour. We can provide this all over the globe and in near real time. Here in this image, you see an example of CB Global. So the colored contours indicate different stages of thunderstorms. The yellow ones are developing clouds. The orange ones are convective turbulent clouds, so convectively induced turbulent clouds. And the red colors indicate mature thunderstorms. Dotted lines are again the 60 minutes nowcasts. So this information would be available in near real time, updated every 5 to 15 minutes, depending on the satellite data used. And for all these clouds identified here, you have information about cloud tops and other attributes like moving speed, moving direction, and so on. And as I already said, the product is available worldwide. In this example, you have an aircraft flying from Zurich to Charles de Gaulle, and imagine the white dotted line is the planned flight route, and it's nighttime. So the pilot at this point, he might see that there is lightning coming up, but he cannot see anything in the onboard radar because of the limited radar range. If he would have CB Global on board of the aircraft, so even if he would only have the contours, he would see that there is thunderstorms coming up here and that they will move in a northeasterly direction indicated by the forecast, and then he could easily contact air navigation control and negotiate an alternate flight route, which is safe. CB Global is not only about flight safety, it's also about efficiency. And we already showed this 10 years ago in a test flight from Rio de Janeiro to Frankfurt in cooperation with Lufthansa. Lufthansa, they had a test electronic flight bag, and they took it on this flight from Rio to Frankfurt. And here you can see a screenshot of this electronic flight bag display. The red areas here are CB Global mature thunderstorms, and the light red areas are the nowcasts up to 1 hour. And here you can see the flight route. So the aircraft was coming up here from the south, and then they saw in the onboard radar thunderstorms coming up, and they decided to divert to the east. And then they diverted and they flew along this light red line. And they could not see this gap here because of the limited range of the onboard radar. So to the left-hand side of the aircraft, one thunderstorm was popping up after the other. And they continued flying to the east, even to the southeast. And then the captain of the aircraft, Andreas Ritter, he decided to upload the CB Global data into his test electronic flight bag. This was around this point here. And then they could see this situation, and they could see that there is a gap coming up, and they decided to turn the aircraft by 90 degrees and verify with the onboard radar what they see here in the electronic flight bag, and then they were finding a safe way through and could continue their flight to Frankfurt. In a post-analysis, Andreas Ritter found also out that if they would have uploaded the CB Global data a little bit earlier, for example at this point here, they could have seen the gap here and they could have saved a 300 nautical miles deviation. That you can fly more efficient by using the CB Global information has also been proven by a scientific study. In this study, we compared the fuel burn of real flown flight routes to the fuel burn of optimized flight routes based on a trajectory optimization tool. In the study, we found out that 0.5 tons of fuel could be saved per flight on average if CB Global information is used in the cockpit. In some flights, in extreme thunderstorm situations, we found out that you can save up to 3 tons per flight. And of course, this is also a CO2 emission reduction potential for each individual flight. One specialty of CB Global is that it can timely warn you of rapidly growing convective turbulence cells. These cells, they do not contain any lightning, they are just rapidly growing from below, and they cannot be seen in the onboard radar or by the naked eye, especially during nighttime. Here I have images of 2 incidents we have investigated, and in both incidents where the aircraft encountered such turbulence cells, we could have warned the pilot already 30 minutes before. So how do we bring these very valuable data into the cockpit of aircraft that pilots can use these data in near real time? Well, the satellite scans the clouds from above. The satellite data are then sent to the CB Global Operation Center at WX Fusion premises. We run our CB Global tool, produce GML, XML data. These data are then sent via a secured internet connection to the Global Data Center of AVTECH. AVTECH is then using communication satellites to send the CB Global data into the cockpit of aircraft, where they are displayed in the ProFlight EFB application of AVTECH. There is only a 6 to 7 minutes delay between the observation time of the satellite and the CB Global product availability in the cockpit. From a technical point of view, this is the best one can do. And with this, I would like to hand over back to Per.
Thank you, Carolina. This picture depicts a screenshot from ProFlight and a picture of the navigation display in an Airbus 320. This was taken by a friend of mine who is a SES pilot, and he wanted to highlight the significant difference between what the regular weather radar can detect and how it is visualized compared to ProFlight. It is fair to say that ProFlight offers a much more detailed and informative depiction of the cumulonimbus clouds compared to the weather radar. In ProFlight, the CB cells and areas of lightning are clearly visible and accurately depicted in real time, providing valuable information to the pilots. Since the ProFlight app is always north-orientated, the previous picture might be a bit confusing, since the aircraft is on a southerly heading. Here we have turned the navigation display 180 degrees to align with the aircraft's orientation. As you can see, the CB cell located south of Degad is not visible on the weather radar in the ND. Pilots value the CB Global layer in ProFlight, that's for sure. This survey, conducted through Typeform, reflects the feedback I receive from pilots worldwide. According to the results, 93% of the pilots rated the accuracy as highly accurate, and 92% rated the overall reliability as highly reliable. Pilots praise ProFlight as a great tool that significantly enhances efficiency and safety in their work. The thunderstorm layer in ProFlight, utilizing CB Global data from WX Fusion, allows users to click on each cell for detailed information about lightning, potential turbulence, and more. It depicts real-time activity and a 1-hour forecast with 4 time steps. In this example, a mature thunderstorm is selected, and the information reveals that its top reaches 37,532 feet. It's moving at 060 degrees with a speed of 4 knots and indicates a growing area. This example illustrates convective turbulence, which is often mistaken for clear air turbulence. ProFlight displays potential turbulence that is not visible on the weather radar due to the lack of precipitation. Convective turbulence can be violent and very dangerous, especially in darkness. In this example, the magenta area in the middle of the track is selected. The turbulence reaches up to 54,461 feet, making it impossible to climb over. It is moving in the direction of 318 degrees at a speed of 5 knots. In summary, ProFlight is an all-in-one EFB weather solution that really can improve and optimize your flight operation. It increases flight safety and comfort while reducing costs, fuel consumption, and CO2 emissions. All features are available for separate users or entire airlines. Please visit avtech.aero/ProFlight for more information and to activate your free trial. And with that, I want to thank you for your time. Once again, please drop us a line if you would like more information or if you have any questions. Thank you.